You are sitting in a room that feels stable. Your body has weight. The air has temperature. Objects remain where you left them. You experience this stability as time moving forward, moment by moment, carrying you from a remembered past toward an unknown future. Nothing about this feels optional. It feels structural. But the measurements used to describe this room, your body, and the signals moving through space do not require time to flow at all. According to the same equations that allow satellites to function and particles to decay, every moment you believe is arriving may already be equally real. Not as a prediction, not as philosophy, as a direct consequence of how time behaves when measured. The conflict is simple to state and difficult to escape. If physics describes reality accurately, then your sense of now has no special status. The question is not whether time passes. The question is whether passage exists at all. The assumption of a moving present. You experience the present as something that advances. It feels like a boundary separating what has already happened from what has not. This assumption is intuitive and universal. Yet no physical measurement has ever identified a moving present. Clocks measure intervals, not flow. Equations describe relationships between events, not a mechanism that carries one event into the next. The present feels fundamental, but it does not appear in the structure of the laws used to describe the universe. This absence is not an oversight. It is not a gap waiting to be filled by a future discovery. The equations that successfully predict planetary motion, atomic transitions, and the behavior of light do not contain a term for a privileged moment. They do not single out now as a physical feature. When physicists write down the state of a system, they specify conditions at a time coordinate, but that coordinate does not move. It is a label, not a process. You might assume that clocks reveal the motion of the present simply by functioning. A second hand sweeps forward. A digital display increments. But what a clock actually does is count repetitions of a physical process. An atom oscillates. A crystal vibrates. A pendulum swings. Each cycle is identical to the last. The clock does not detect time flowing past it. It compares one state of itself to another. Nothing in its operation requires the universe to advance. If the present were a physical thing that moved, it would have consequences. Motion produces effects. A moving object has a velocity. It can be measured relative to something else. A moving present would need a rate. It would need to move relative to something. No experiment has ever detected such a rate. No reference frame reveals the present advancing. The laws remain complete without it. You may object that the present must be real because you experience it directly. But physics does not take experience as a primary measurement. It takes reproducible observation. Two observers can agree on distances, durations, and sequences, but they cannot agree on a shared now unless they are at rest relative to each other. Even then, that agreement breaks down when compared to a third observer in motion. The present fragments. It cannot be made universal. This becomes unavoidable in relativity. Events that you classify as happening now can be classified as already past or not yet occurred by another observer moving differently. Both descriptions are correct. There is no deeper layer where one of you is wrong. If the present were an objective feature of the universe, it would not depend on who is observing it. The idea of a moving present persists because it feels necessary to explain change. Things change, so it seems natural to conclude that time must be passing. But change does not require passage. A film reel contains every frame of a movie at once. The story unfolds when the frames are experienced in sequence, but the reel itself does not change as the story progresses. The difference between frames exists without motion. Physics treats reality in a similar way. It describes a set of events arranged in space-time. Each event is distinct. Each has relationships to others. The differences between them account for everything you call change. What is missing is any indication that one event becomes real while another waits its turn. The assumption of a moving present is powerful because it aligns with how you navigate the world. You plan, you anticipate, you remember. These activities depend on asymmetries in information and memory, not on a flowing moment. The structure that supports your experience does not require time to advance. It requires only that different states exist and that you occupy them in a particular order. What remains unsettling is how natural the assumption feels despite its absence from measurement. The present seems undeniable, yet it leaves no trace in the equations that describe reality with extreme precision. You live as if now is arriving, but the universe behaves as if every now already exists. Time as a coordinate, not a process. In physics, time is treated the same way as space, as a coordinate used to locate events. An event is defined by where and when it occurs, not by whether it is past or future. The equations remain valid regardless of which direction time is labeled. Nothing in the mathematics requires time to advance. This suggests that what you experience as passage may not be a feature of the universe, but a feature of how you occupy it. When physicists describe motion, they do not say that objects move because space is flowing. Space provides a framework within which positions differ. Time functions in the same role. It distinguishes one event from another without implying that one is becoming real while another is fading away. The coordinate marks separation, not progression. This becomes clear when considering how equations are written. The same mathematical structure can describe a system forward or backward in time. If the sign of the time coordinate is reversed, the relationships between events remain intact. Predictions still follow. The laws do not break. A process that truly flowed would impose a preferred direction. Time, in its mathematical role, does not. You might expect that treating time like space would allow movement through it in the same way you move through a room. But this analogy fails at a deeper level. You can choose different paths through space. You cannot choose different paths through time. Every physical process traces a single path through the time coordinate. This restriction is not imposed by time flowing. It is imposed by causality, which orders events without requiring motion. The distinction matters because it removes the need for a temporal engine. Nothing pushes events forward. They are simply arranged. Each state of a system corresponds to a location in space-time. The next state is not created by the previous one advancing. Both states already belong to the structure being described. This perspective becomes unavoidable in relativity, where space and time are combined into a single entity. Events are points in this four-dimensional framework. What you call the present is a slice through that structure, defined by your state of motion. Another observer slices it differently. Both slices cut through the same set of events. Neither defines what is real. If time were a process, its flow would need to be independent of the systems within it. It would need to carry particles, fields, and observers along. But no such carrier appears in the equations. The motion of particles is described relative to coordinates, including time, not by being swept along by them. The coordinate view also explains why clocks behave the way they do. A clock does not reveal time moving. It reveals how much of the time coordinate separates two events along its path. Different clocks can register different separations between the same events if their paths differ. This is not a malfunction. It is a consequence of time functioning as a dimension. Your experience resists this interpretation because it compresses information. At any moment, you only have access to records from certain regions of space-time. Memories exist in one direction. Anticipations exist in the other. This asymmetry produces the sensation of passage. But the sensation arises from how information is distributed, not from how time behaves. Treating time as a coordinate does not deny change. It reframes it. Change becomes the comparison between different locations in space-time. The universe does not update itself. It does not require a present to move. It contains variation, and that variation is enough to account for every observed process. What remains unresolved is why this static description gives rise to a dynamic experience. Physics describes where events are. It does not explain why you experience them in sequence. The coordinate captures structure, not awareness. And yet, the structure it describes leaves no room for time to be anything more than a label. Relativity removes a universal. Now, special relativity demonstrates that simultaneity depends on motion. Two observers moving differently will disagree about which events are happening at the same time. There is no single slice of the universe that can be labeled the present for everyone. If a universal now existed, it would appear consistently in measurements. It does not. The present fractures into observer-dependent perspectives. This result is not philosophical. It is derived directly from how light behaves. The speed of light is measured to be the same for all observers, regardless of their motion. Accepting this single fact forces a revision of how time is assigned to events. To preserve that constancy, clocks moving relative to one another cannot remain synchronized in a universal way. What one observer calls now, another must divide into past and future. You do not notice this in daily life because the effect is small at ordinary speeds. But small does not mean absent. The disagreement exists in principle and becomes measurable at high velocities. Experiments confirm it. The fracture in the present is not theoretical. It is operational. Consider two distant events, far enough apart that light from one has not yet reached the other. For you, standing still relative to both, they may appear simultaneous. For an observer moving toward one and away from the other, the timing changes. One event occurs earlier, the other later. Neither observer is privileged. There is no deeper temporal layer where simultaneity is restored. If the present were a physical feature of the universe, this disagreement would be impossible. A real, objective now would impose itself on all observers, regardless of motion. It would act as a global constraint. Relativity shows that no such constraint exists. The laws remain consistent without it. This forces a choice. Either you reject the experimental evidence, or you accept that the present is not universal. Physics chooses the latter. It does so not reluctantly, but necessarily. The equations work because they abandon the idea of a shared now. What replaces it is a network of local times, each tied to an observer's motion. Every observer carries their own definition of simultaneity. These definitions overlap and intersect, but they never align globally. The universe does not agree on what is happening right now. This is unsettling because it undermines a deeply held assumption that reality is synchronized. You expect the universe to have a current state. Relativity denies this. It replaces the idea of a current state with a set of relationships between events. Reality becomes relational rather than moment-based. The consequences extend beyond simultaneity. If there is no universal now, then the division between past, present, and future cannot be absolute. Events you consider future may already be present in another observer's frame. Events you consider past may still be unfolding elsewhere. The ordering is not erased, but its interpretation changes. Importantly, this does not allow contradictions. No observer can witness an effect before its cause. Causality remains intact. What dissolves is the notion that all observers share the same temporal partitioning of events. The universe enforces order without enforcing a present. You might try to rescue the present by suggesting it exists, but is hidden, undetectable by measurement. But a feature that has no measurable effect cannot be distinguished from a feature that does not exist. Physics does not recognize invisible absolutes. It recognizes structures that influence observation. Relativity replaces the present with something quieter and more rigid. A space-time structure where all events are placed in relation to one another, but none are marked as happening now. The experience of a present moment becomes something that occurs within this structure, not something that defines it. This leaves a persistent tension. You experience a now that feels immediate and singular. Physics describes a reality that cannot support it universally. The conflict is not resolved by better instruments or deeper theories. It is built into the way motion and measurement work. Once simultaneity is lost, the present loses its authority. It becomes local, temporary, and dependent. And once that happens, the idea that time flows through a shared moment becomes increasingly difficult to sustain. The block of events. When time is treated as a dimension, the universe resembles a four-dimensional structure containing all events. Past, present, and future exist as locations within this structure. Nothing moves through it. Events simply are. This model is not speculative. It is the natural consequence of combining space and time into a single framework that accurately predicts observations. In this framework, an event is not something that happens and then disappears. It is something that occupies a position. Just as a mountain does not cease to exist when you stop looking at it, an event does not cease to exist when it is no longer present to you. It remains fixed within the structure. What changes is your relationship to it. The idea feels abstract because it contradicts how you experience life. You feel yourself progressing. You feel moments arriving and leaving. But the block model does not deny that experience. It denies that the experience reflects how the universe is arranged. It treats experience as a path traced through an already existing structure. This interpretation follows directly from relativity. Once space and time are unified, it becomes inconsistent to treat time as something that unfolds while space remains static. Both are part of the same entity. If spatial locations exist regardless of whether you are there, then temporal locations must be treated the same way. Consistency demands it. In the block, there is no privileged direction. Earlier and later are relational terms, not indicators of becoming. One event lies before another along a world line, but neither is more real than the other. The distinction you draw between past and future is not a distinction the structure itself makes. You might imagine the block as frozen, but that image is misleading. Frozen implies halted motion. The block contains motion. It contains every movement, every change, every process. What it lacks is an external clock that advances the whole. Motion occurs within the structure, not to it. This resolves certain puzzles while creating others. It explains why the laws of physics do not reference a present moment. They do not need to. All moments are already included. The equations describe relationships across the block, not updates to it. It also explains why relativity works so cleanly. Different observers move along different paths through the same structure. Each path intersects different sets of events at different coordinates. No observer's path defines what exists. It only defines what is experienced. From this perspective, the future is not something that comes into being. It is something you have not yet encountered along your path. The past is not something that has vanished. It is something that lies behind you in the structure. Both are equally fixed. This interpretation becomes uncomfortable when applied to choice and action. Decisions feel like they generate new outcomes. In the block, decisions are events with consequences already encoded in their relationships to other events. The feeling of openness reflects uncertainty about what lies ahead on your path, not indeterminacy in the structure itself. Importantly, this does not require strict determinism. Probabilities can be built into the block. Quantum events can branch. The structure can contain multiple possible outcomes, each occupying its own region. What remains unchanged is the absence of a moment where possibilities become real. They already are. The block model is not an additional hypothesis layered on top of physics. It is what remains when nothing extra is added. When time is treated only as the equations require, without importing assumptions from experience, this is the picture that emerges. What disturbs is not that the block is strange. It is that it is mundane. It arises quietly from principles that have been tested for over a century. There is no dramatic experiment that reveals it. No single observation announces it. It is simply the shape reality takes when described without privileging your point of view. You still wake up. You still anticipate. You still remember. None of that disappears. But beneath those experiences lies a structure that does not share their urgency. A universe where nothing waits to happen, because nothing needs to. Why motion through time is not measured. You feel yourself moving through time, but no experiment has ever detected such motion. Velocity through space is measurable because it produces effects. A velocity through time would also produce effects if it existed. None are observed. The equations remain complete without it. The sensation of movement lacks a physical counterpart. In physics, motion is defined by change relative to a reference frame. An object's velocity through space can be measured because it alters how forces act, how energy is distributed, and how signals propagate. A moving object experiences time differently, emits radiation differently, and interacts differently with other systems. Motion leaves traces. It is never hidden. If you were moving through time in any analogous sense, that motion would need to be defined relative to something. A background time, a meta-time, a second temporal dimension against which the first advances. Without such a reference, the concept of velocity becomes undefined. No physical theory includes such a structure. You might argue that the reference is simply the present itself, advancing from moment to moment. But this only restates the assumption. It does not provide a measurable framework. A velocity that cannot be expressed relative to any coordinate or field cannot produce observable consequences. Physics cannot accommodate it. The absence of effects is decisive. A temporal velocity would alter measured durations in a systematic way. It would introduce asymmetries beyond those already accounted for by relativity and gravity. It would require corrections to equations that already match observation with extreme precision. No such corrections are needed. Clocks do not detect motion through time. They do not speed up or slow down because time itself is moving. They change rate only due to motion through space or gravitational potential. These effects are predicted and confirmed. There is no residual discrepancy that could be attributed to an underlying temporal flow. This is not because experiments are insufficiently sensitive. Modern timekeeping can detect differences of less than a billionth of a second. Atomic clocks placed a few centimeters apart tick at different rates due to gravity. Yet no experiment has ever revealed an offset attributable to a universal motion through time. The feeling of movement persists despite this absence. You feel carried forward. But physics draws a distinction between feeling and force. Many sensations arise from internal processing rather than external motion. Balance, continuity, and temporal order are constructed by systems that track change, not by systems that detect flow. Consider how you perceive motion in a stationary train when another train passes. The sensation is compelling. It feels real. Yet it disappears when a stable reference is introduced. Temporal motion lacks even the possibility of such a correction. There is no external frame against which it can be resolved. Every physical process already includes time as a parameter. Adding motion through time would double count it. It would require explaining why systems evolve in time while also being carried through it. The redundancy is unnecessary. The simpler description, without temporal motion, works. This simplicity is not aesthetic. It is empirical. Theories that introduce extra structure without necessity are discarded because they fail to improve predictions. Time, as a coordinate, explains all observed behavior. Time, as a flowing entity, explains none that cannot already be explained. The idea of motion through time also conflicts with relativity. Different observers experience different rates of time. If all were being carried forward by a universal flow, those differences would require additional mechanisms. None are observed. The relative nature of time becomes incoherent if an absolute motion is imposed beneath it. What remains is a gap between description and experience. You feel motion without measurement. You experience progression without velocity. Physics does not deny the experience. It refuses to treat it as evidence of an external process. The sensation of how moving through time may be real in the same way color is real. It reflects how systems interpret information, not how the universe is structured. There is no detector for temporal motion because there is nothing to detect. Once this is accepted, the absence becomes conspicuous. A concept that feels unavoidable leaves no imprint. It does not bend equations, alter trajectories, or shift clocks. It exists only in the perspective of the observer. And that raises a more unsettling possibility, that what feels like the most fundamental motion of all is not a motion at all. Clocks do not advance. The universe. Clocks are often taken as evidence that time flows. But clocks do not cause time to pass. They count repeated physical processes, an oscillation, a decay, a vibration. Each clock measures change relative to itself, not progression through a universal temporal current. The universe does not tick. Only systems within it do. This distinction is subtle but essential. When you look at a clock, it feels like you are watching time move. The hands advance. The numbers change. But nothing external is being measured. The clock is comparing one internal state to another. It is a closed loop of physical change, calibrated to repeat reliably. It does not detect time. It defines a unit and counts how many times a process completes. Every clock works this way. A mechanical clock relies on the periodic motion of gears. An atomic clock relies on the frequency of radiation emitted by electrons transitioning between energy levels. A radioactive clock relies on decay rates. None of these processes require time to flow. They require only that physical laws relate one state to another. If time itself were advancing the universe, clocks would behave differently. They would be passive indicators, responding to an external progression. But clocks are active systems. They function even in isolation. A clock drifting through empty space will continue to operate without reference to anything else. It does not need to be immersed in a moving present. This becomes clearer when clocks disagree. Relativity predicts that clocks following different paths through space-time will record different amounts of elapsed time between the same two events. This is not because time flows differently in different places. It is because the paths themselves are different. The clock measures its own history, not a universal duration. If clocks revealed an underlying temporal current, they would remain synchronized, regardless of motion or gravity. They do not. Their divergence is precise, predictable, and fully explained without invoking any flow. Time dilation affects clocks because it affects the geometry of space-time, not because time speeds up or slows down as a substance. The language you use obscures this. You say time passes because the clock advances. But the clock advances because physical processes occur in sequence. The direction of explanation matters. The clock does not reveal passage. Passage is inferred from the clock. This inference is reinforced by coordination. When multiple clocks agree, it feels like they are all tracking the same moving thing. But agreement does not imply flow. It implies shared calibration. Synchronization is achieved by exchanging signals and adjusting rates. It is an engineering problem, not evidence of a cosmic rhythm. Even the most precise clocks reveal nothing beyond local change. They cannot detect whether the universe as a whole is progressing. There is no master clock outside the universe against which these devices are being compared. Without an external reference, the idea of advancement loses meaning. You might imagine rewinding a clock to reverse time. But rewinding only alters the clock's internal state. It does not reverse the events that occurred while it was running. The universe does not follow the clock. The clock follows the universe's structure. This becomes especially clear in cosmology. The expansion of the universe is not driven by time advancing. It is described as a relationship between distances that changes with the time coordinate. The clock does not push galaxies apart. It records intervals along world lines as the geometry evolves. The belief that clocks advance the universe persists because clocks are the most familiar interface with time. They sit on walls. They govern schedules. They punctuate experience. But familiarity is not evidence. When examined closely, clocks turn out to be evidence of the opposite. That time is something measured, not something that moves. What remains is a mismatch between function and interpretation. Clocks work perfectly without requiring time to flow. Physics describes them completely without invoking passage. And yet, the act of watching a clock creates the impression that something is being carried forward. Once that impression is stripped away, clocks become less comforting. They no longer reassure you that the universe is keeping pace. They simply register change, indifferent to meaning. They do not mark the arrival of the present. They only record that one state has followed another in a universe that does not need to advance for either to exist. Time dilation. Without a preferred rate. Relativity shows that different observers experience different amounts of time between the same events. This is not an illusion. It is measured. If time flowed uniformly, such discrepancies would be impossible. The fact that time can stretch and compress depending on motion and gravity suggests it is not a single advancing entity, but a variable relationship between events. Time dilation is not inferred indirectly. It is observed. Atomic clocks placed on airplanes return showing less elapsed time than identical clocks left on the ground. Satellites must correct for both their speed and their distance from Earth's gravitational field in order to function. Without these corrections, navigation systems fail. The effect is real, consistent, and quantitatively precise. If time were something that flowed, it would require a single rate of flow. That rate could vary only if there were a mechanism to slow it down or speed it up. Relativity provides no such mechanism because it does not treat time as a substance. It treats it as a dimension whose geometry depends on motion and gravity. The variation arises not from time changing its behavior, but from observers following different paths. Each observer carries their own clock. That clock measures the length of the path taken through space-time between two events. Different paths have different lengths. The clocks do not disagree because time is malfunctioning. They disagree because the structure they are embedded in is not flat. This removes the idea of a preferred rate. There is no master tempo that all clocks approximate. There is no universal second ticking in the background. Every clock measures its own proper time. Proper time is not a fraction of a global flow. It is a local quantity, defined only along a specific world line. The absence of a preferred rate matters because it eliminates the possibility of time flowing independently of observers. A flow would imply a standard pace. Deviations from that pace would need explanation. Relativity offers none because it does not require one. The variation is fundamental. You may be tempted to say that time still flows, just at different speeds for different observers. But this language introduces a contradiction. Speed is defined relative to something. Different speeds require a common frame of reference. There is no such frame for time itself. Each observer's measurement is complete without comparison. Gravity reinforces this conclusion. Clocks deeper in a gravitational field run more slowly relative to clocks farther away. This effect has been confirmed near Earth, near massive objects, and in orbit. If time flowed uniformly, gravity would need to interfere with that flow in a consistent way. Instead, gravity alters the geometry of space-time. The clocks respond to geometry, not to flow. What these measurements reveal is not that time behaves strangely, but that the assumption of uniform passage was misplaced. The expectation of a single advancing rate is imported from experience, not from observation. Physics replaces it with a structure where durations depend on position and motion. The unsettling implication is that there is no answer to the question of how fast time is passing. The question assumes a global process that does not exist. Asking for the speed of time is like asking for the speed of space. The concept does not apply. Yet your experience insists otherwise. You feel time accelerating or slowing in familiar situations. Waiting feels long. Sudden events feel brief. These sensations correlate poorly with physical time dilation. They arise from cognitive processing, attention, and memory. They are internal, not geometric. Physical time dilation does not care how events feel. It accumulates silently. A clock in orbit does not experience excitement. It simply records fewer oscillations between events. The difference is invisible until the clocks are compared. Once compared, the conclusion is unavoidable. Time does not pass at the same rate everywhere. And without a single rate, the idea of time flowing becomes incoherent. There is nothing to flow uniformly, nothing to slow down, nothing to speed up. What remains is a relational picture. Events are separated by intervals that depend on how they are connected. Duration is not something that moves. It is something that differs. The universe does not keep time. It allows time to be measured, locally, inconsistently, and precisely. And in doing so, it offers no place for a universal advance, only for paths that accumulate different amounts of what clocks record. Gravity alters duration, not sequence. In strong gravitational fields, time runs more slowly relative to distant observers. This effect is measured near Earth and in orbit, yet the order of events remains consistent. Gravity changes how much time accumulates, not what happens first. This reinforces the idea that time measures intervals, not passage. The slowing of clocks in gravity is not a metaphor. It is a measurable difference in accumulated time between identical systems placed at different gravitational potentials. A clock on the surface of Earth ticks more slowly than a clock on a satellite. A clock closer to a massive object records fewer oscillations than one farther away. These differences persist even when the clocks are later compared directly. What matters is what does not change. Events do not reorder themselves. Causes remain before effects. Signals still propagate outward. Gravity does not cause tomorrow to arrive before today. It alters duration without disrupting sequence. This distinction reveals something important about what time is doing in physical theory. If time were flowing as a process, gravity would need to interfere with that process in a way that could disrupt order. Slowing a flow risks accumulation, compression, or overlap. None of this occurs. The structure of events remains intact. General relativity explains this by treating gravity not as a force acting within time, but as curvature of space-time itself. Mass and energy alter the geometry through which clocks move. A clock in a deeper gravitational well follows a different path through space-time than one higher up. The difference in elapsed time reflects geometry, not resistance to flow. This geometric explanation is precise. It predicts the amount of time difference to extreme accuracy. It requires no additional assumptions about how time behaves. There is no friction, no drag, no temporal medium being slowed. There is only difference in path length. If you imagine two hikers walking between the same points along different trails, one longer and one shorter, they arrive at different times without any change in walking speed. Gravity produces an analogous effect. The clocks traverse different space-time paths. The accumulated time differs. The order of step does not. This is why gravity can alter duration without threatening causality. The structure of space-time constrains which events can influence others. Those constraints remain intact even as durations vary. The universe preserves order without preserving uniformity. The persistence of sequence is critical. It shows that what matters physically is not the advance of a moment, but the arrangement of events. Gravity reshapes the arrangement without introducing a moving present. Time does not need to flow for its intervals to change. You might expect that a slowing of time would be felt locally, but an observer near a massive object does not experience anything unusual. Their clock behaves normally. Their processes unfold as expected. It is only in comparison that differences emerge. Time dilation is relational, not absolute. This reinforces the idea that time has no global behavior. There is no master clock slowed by gravity. Each clock measures its own duration. The universe does not coordinate them into a single rhythm. If time were passing as a universal process, gravity would need to modify that process locally. It would need to know where mass is and adjust accordingly. No such mechanism appears in the theory. Gravity alters geometry, and geometry determines durations. The fact that sequence survives while duration varies suggests that time's role is bookkeeping, not propulsion. It records how events are separated. It does not push them along. This is uncomfortable because it strips time of agency. The slowing of clocks feels like interference with something active. In reality, nothing is being slowed. Different clocks simply trace different lengths through space-time. Once this is accepted, the picture becomes stark. The universe allows durations to differ while preserving order. It does not require time to move for this to happen. It requires only structure. Gravity, in this sense, reveals what time is not. It is not a current carrying events forward. It is a measure of separation shaped by geometry. And geometry can change without anything flowing at all. Causality. Without flow, causes precede effects, but this ordering does not require time to move. It requires only that events be ordered within space-time. The structure enforces which events can influence others. Causality survives, even if all events already exist. What disappears is the idea that the future is waiting to happen. Causality is often confused with temporal passage. You observe that one event leads to another and conclude that time must be carrying the cause into its effect. Physics does not make this leap. It defines causality as a constraint. Certain events can affect others, and certain events cannot. This constraint is geometric, not dynamic. In relativity, the structure of space-time divides events into categories. Some are in your past light cone. Some are in your future light cone. Some are elsewhere, unable to influence or be influenced by you. This division is fixed by the geometry of space-time and the speed at which information can travel. It does not depend on time advancing. Once the structure is set, the order of influence is determined. An effect cannot occur before its cause, because the geometry does not allow information to travel that way. No flow is required. The constraint is already there. This remains true even in a block universe. All events can exist without undermining causality. Their relationships are encoded in the structure. The fact that an effect lies later along a world line than its cause does not require the cause to push the effect into being. It requires only that the two are ordered. You might think this removes the force behind causation, but causation in physics is not a force. It is a description of allowed correlations. When a particle decays, it does not cause the next moment to happen. It occupies a location in space-time where a decay event is correlated with other events. The law describes that correlation. It does not animate it. The idea that the future is waiting arises from how you experience uncertainty. You do not know what will happen next, so it feels as though it has not yet occurred. But ignorance is not absence. Physics distinguishes between what is unknown and what does not exist. The equations operate on the former assumption. This distinction becomes important when considering predictions. When you calculate where a planet will be, you are not bringing that position into existence. You are identifying a point in space-time consistent with known constraints. The calculation works because the structure is already defined. Even in quantum mechanics, where outcomes are probabilistic, causality is preserved. Probabilities describe distributions of events, not their creation. The framework constrains which outcomes can follow which measurements. The uncertainty lies in which branch is realized in your experience, not in whether the structure exists. The loss of flow does not collapse cause and effect into simultaneity. Order remains. It is enforced by space-time intervals. Time-like separation preserves sequence. Space-like separation preserves independence. These distinctions are mathematical, not experiential. You may still insist that causation feels active. Pressing a button feels like it makes something happen. But the feeling reflects how your actions are embedded in a sequence you occupy. The button press and the outcome are correlated events along your world line. The sense of production is internal to that sequence. The block view reframes this. The button press does not bring the outcome into existence. Both exist as events connected by lawful relationships. The experience of causing reflects your position in that network, not a universal process of becoming. This reframing is unsettling because it removes the sense of an open future. If all events exist, the future is not waiting. It is located. What you experience as anticipation is a lack of access, not a lack of reality. Causality, stripped of flow, becomes austere. It is not about time pushing forward. It is about structure permitting influence in one direction and not the other. The universe does not need to move for causes to precede effects. It only needs to be arranged in a way that forbids the reverse. What vanishes is the comforting idea that the future is empty until you arrive. What remains is a universe where order is fixed, influence is constrained, and the sequence you experience is a path through something already complete. The absence of a creation moment. If time were flowing, the universe might require a present moment at which creation is occurring. But cosmological models describe the early universe as a boundary condition, not an on-wing emergence. The Big Bang is not a moment that happened and passed. It is a region of space-time with specific properties. The distinction is crucial. The origin of the universe is not a point in which reality began to advance. It is a limit within the equations that describe space-time and matter. Physical laws apply from that boundary outward. There is no moment outside the universe into which creation spills. There is only the structure itself. This is reinforced by general relativity. The equations describe how space-time curves in response to energy and matter. They extend backward to the earliest moments, but the mathematics does not require a temporal flow carrying the universe into existence. The initial singularity, or near singularity, is simply a boundary condition, a starting point for the equations. Nothing is becoming at that boundary. You might imagine the Big Bang as a dramatic explosion, something erupting into being. That intuition is shaped by everyday experience, where objects appear and events begin. Cosmology is not constrained by this intuition. The Big Bang is not a temporal process in the sense of unfolding from nothing. It is a description of a configuration from which all subsequent events can be calculated. Measurements support this view. The cosmic microwave background, the distribution of galaxies, and the abundances of light elements are all consistent with initial conditions at the Big Bang. They constrain properties, temperatures, and densities, but they do not record the universe being created in a moment of flow. They describe relationships across space-time that are consistent with a fixed initial boundary. Even the notion of before the Big Bang becomes problematic. Time coordinates are tied to the geometry of space-time. Extrapolating backward reaches the boundary, but the concept of a moment prior loses meaning. There is no universal clock outside the universe to measure a preceding instant, the creation moment. You imagine has no physical definition. This has implications for how you think about beginnings. The universe does not emerge progressively from a present. It exists as a set of events, with the earliest defined by boundary conditions. What you experience as the passage from nothing into something is an artifact of perspective, not a feature of reality. Quantum cosmology reinforces this. Models such as the Hartley-Hawking state treat the beginning as a region without classical time. There is no flowing moment of creation, only a probability distribution over configurations. Events emerge from the structure without requiring a present to carry them forward. The absence of a creation moment also clarifies why laws of physics are timeless. The equations governing the universe are not themselves evolving. They are defined for the entire space-time. There is no meta-time in which the laws are being applied. They operate across the block without the need for an advancing present. Your perception of a beginning is tied to memory and causality. You infer a past from present states. You assign sequence to events. But these are internal constructions. They do not imply that the universe required a temporal origin in which it was coming into being. The effect is subtle but pervasive. It challenges the notion that the universe is emerging in stages: expansion, structure formation, star birth. These are real processes within space-time. They unfold along coordinates, but they do not rely on a universal present moving forward. Their reality does not require a creation moment. Ultimately, the absence of a creation moment emphasizes the distinction between experience and structure. The universe does not wait for a present to arrive to become. It is already laid out, bounded, and complete in the sense defined by physical theory. What you perceive as a beginning is only the first point along a coordinate, not a moment that advances. The universe exists not as a sequence being constructed, but as a structure in which all events, including what you call the beginning, are located. Entropy and the illusion of direction. The arrow of time is often attributed to increasing entropy. Disorder increases toward what you call the future. But entropy describes statistical behavior, not temporal motion. It explains why you remember the past and not the future, not why time itself would flow. Entropy is a measure of the number of ways a system can be arranged while still appearing the same macroscopically. It does not require that time is moving to increase. The second law of thermodynamics is a statement about probabilities. Given a low entropy configuration, the vast majority of accessible states are higher in entropy. Systems evolve toward these states because they are overwhelmingly more numerous, not because time propels them forward. Consider a gas expanding in a container. It spreads from a concentrated state to a uniform one. This is often described as motion through time toward disorder. But the statistical rules that govern particle distributions are indifferent to a temporal flow. They predict the configuration from any given state. The gas does not need a moving present to reach a more probable arrangement. The probability gradient itself accounts for the change. This explains why you can remember the past but not the future. Memories form in low entropy states and correlate with preceding higher entropy states. Your brain encodes information in configurations constrained by prior states, creating a directionality in experience. But this directionality is epistemic, not physical. It describes how information is stored and transmitted along your world line. It does not indicate that the universe itself is advancing. Entropy also clarifies why thermodynamic irreversibility is compatible with a block universe. All events, low entropy and high entropy, exist within space-time. The increase of disorder is a pattern within the structure, not a marker of progression. From a four-dimensional perspective, the gradient exists across events. No underlying flow is required for the pattern to manifest. You perceive sequence because your consciousness occupies a specific path, moving from low to high entropy along that path, not because the universe itself is moving. Even cosmic entropy follows this principle. The early universe was highly ordered. Over billions of years, stars form, evolve, and die. Structures collapse, gases mix, and black holes grow. Observations confirm this progression statistically. Yet the equations describing these processes require only initial conditions and physical laws. They do not invoke a passage of time beyond the relationships between events. Entropy increases along world lines, but there is no engine pushing the universe forward. Entropy's arrow is therefore a directional relationship, not a current. It correlates sequences of states. It explains why phenomena appear asymmetric without implying that time itself is asymmetric. Reversing the arrow is conceivable mathematically. The laws themselves are time-symmetric. The perceived asymmetry arises from boundary conditions, initial low entropy, and the constraints imposed on your path through space-time. Your experience reinforces the illusion. You live along a trajectory where disorder grows. You infer that this direction must be fundamental, but this is an artifact of your location within the block of events. Other slices of space-time could contain reversed gradients or different patterns entirely. What you call the future is simply the part of the structure that exhibits higher entropy relative to your position. Even in thought experiments, the same principle holds. A perfectly isolated system with low entropy will evolve predictably toward higher entropy. Reversing every particle's velocity would produce apparent time reversal. Yet the underlying laws remain unchanged. Nothing in these dynamics requires a universal clock or a moving present. The statistical tendencies exist regardless of perception. Ultimately, entropy demonstrates that the arrow of time is emergent, not fundamental. It governs correlations, memory, and experience, not flow. The universe does not advance into disorder. Disorder is a description of relationships between events already contained within the structure. What you perceive as progression is a consequence of your trajectory through these patterns, not the movement of time itself. The unsettling realization is that every increase in disorder, the unfolding of stars, the melting of ice, the decay of memories, is consistent with a universe where nothing is passing. The direction you feel is real, measurable, and undeniable, yet it requires no flow at all. It is structure masquerading as movement, sequence masquerading as passage, probability masquerading as a current, memory as a physical asymmetry. You remember earlier events because records exist in one direction. Photons scatter. Structures persist. This asymmetry creates a psychological sense of movement. But memory depends on physical processes that already exist within space-time. It does not require time to be advancing. Memory is encoded physically. Synapses change. Molecules are rearranged. Information is stored in stable configurations. These changes are themselves events situated within space-time. The events that encode a memory exist alongside the events they describe. Nothing about the memory itself implies that the past is being carried forward, or that the present is moving toward the future. It exists because the structure allows it. Consider a photograph. The image captures light that reflected off objects long ago. The photograph is fixed in its state. It does not advance. The information contained in it represents earlier configurations. Your perception interprets it as past because you occupy a world line later than the events depicted. The sense of passage arises from your location within the block, not from the image being transported through time. This principle applies universally. Fossilized bones, sedimentary layers, cosmic microwave background radiation, all are records embedded in space-time. They indicate a sequence, not an ongoing creation. Each record exists at a specific location along the time coordinate. The asymmetry between what is recorded and what is not creates the impression that time moves in one direction. But the underlying reality does not. The asymmetry is reinforced by entropy. Systems that retain information tend to emerge in regions of lower entropy relative to their surroundings. Stable records accumulate because the laws of physics allow them to persist. High entropy states destroy correlations. This is why you cannot remember the future. The structures encoding it do not exist along your path. Memory is directional because the physical substrate is directional, not because time itself is flowing. Neuroscience supports this interpretation. Neural activity encodes sequences by physically linking states. Signals travel along axons, chemical gradients shift, synapses strengthen. These processes require time coordinates to describe change. But the fact that you experience recall as a journey from past to present does not imply a moving present. It reflects correlations among events along your world line. The brain interprets differences between one set of states and another, producing awareness of sequence without producing movement. Memory also illustrates why the arrow of time feels immediate. You perceive events unfolding because earlier states leave traces in later states. Each event carries information forward. The causal relationships encoded in the physical world determine the order in which your consciousness reconstructs experience. This order is consistent and measurable. Yet at no point does anything need to flow to make it so. The structure already contains every step. Even complex forms of memory obey this principle. Planning, anticipation, and imagination rely on the brain accessing records of prior events and projecting correlations into future configurations. The processes are physical. Neurons fire, chemical states evolve. The experience of moving from memory to anticipation feels like a temporal current, but it is a sequence of static states interacting. Passage is a feature of interpretation, not of existence. Cosmologically, this principle extends beyond observers. Records of early universe conditions exist in the distribution of galaxies, in the temperature variations of the cosmic microwave background, in isotopic abundances. They mark a direction because structures persist in a particular order. The asymmetry is objective, observable, and measurable, yet it arises from arrangement, not from motion. The consequence is profound. The certainty you feel about the past, your conviction that it has occurred, is a consequence of records embedded in space-time. Your sense of a flowing present, of moving from past to future, is an emergent phenomenon of correlations along your path. The block universe contains all events, yet the physical asymmetry of memory gives the illusion of passage. In this way, memory is both real and misleading. It anchors you, gives context, and orders experience, while simultaneously obscuring the underlying structure of reality. You feel carried forward, yet there is nothing carrying you. What you call recollection is not evidence of movement, but evidence of arrangement, a fixed asymmetry in the spatial temporal tapestry that you inhabit. Prediction. Without becoming physical laws, allow predictions. But prediction does not imply that events are not already real. A map can describe a landscape without causing it to form. Similarly, equations can describe future events without requiring them to come into existence later. Consider how a physicist calculates the trajectory of a planet using Newton's or Einstein's equations. The future position of the planet is determined from current conditions. The calculation does not create the planet's path. It only describes it. The outcome exists as an event in space-time, whether or not anyone computes it. The planet does not move into existence because the prediction is made. It occupies coordinates that satisfy the laws. This distinction becomes more striking in cosmology. When scientists model the formation of galaxies or the evolution of the cosmic microwave background, they are not generating new events. They are uncovering relationships between conditions already encoded in the universe's structure. The equations are descriptive, not creative. Predictions reveal the underlying block, not a future that is waiting to occur. Quantum mechanics illustrates this principle in a subtler way. Probabilities allow you to calculate the likelihood of different measurement outcomes. Before measurement, the universe already contains all possibilities as potentialities within the wave function. Predicting which outcome will appear does not bring it into being. The laws of quantum physics describe correlations between events, not a temporal process that generates them. Measurement selects a branch for observation, but the structure of possible outcomes is already fixed. Prediction, in this sense, is epistemic rather than ontological. It is about knowledge, not creation. You use equations to anticipate what will be observed along your path through space-time. Those observations exist independently of your calculation. The laws of physics are consistent across all frames, providing accurate predictions without requiring a universal becoming. Even everyday experiences follow this pattern. When you forecast tomorrow's weather, you do not cause the wind to blow differently or the clouds to gather. The forecast is a model of dynamics that are already constrained by physical laws. The outcomes unfold according to relationships, not because a temporal current is carrying them into reality. Prediction exposes these constraints. It does not instantiate events. Mathematically, this is evident in deterministic systems. Differential equations describe how variables change in relation to one another. Solving the equations allows you to know a future state, but the solutions exist independently of the act of solving. The variables are already linked by the structure of the equations. Computation uncovers patterns. It does not propel them forward. The distinction has philosophical implications. You feel the future is open because you can predict it imperfectly. Uncertainty and partial knowledge give the impression of novelty. Yet, from the perspective of space-time as a structure, the future already exists. Your calculations are a window into it, not a tool that creates it. What appears emergent is simply what is encountered along your world line. Even in chaotic systems, where small changes amplify unpredictably, prediction does not create outcomes. Sensitivity to initial conditions affects accuracy, not reality. The events exist. Your knowledge of them is what is incomplete. Prediction is about modeling correlations under constraints, not about generating new events in time. The block universe emphasizes this principle. All events, past, present, and what you call future, occupy positions within the structure. Laws of physics define the relationships among them. When you predict, you are tracing the implications of those relationships. There is no requirement for the predicted events to be carried into existence by time itself. They are already there. What is revealed by this perspective is unsettling, yet precise. Anticipation, planning, and foresight are all real processes. They are grounded in the causal and statistical structure of the universe. But the reality you anticipate is not emerging from nothing. It is waiting in a sense, not in the temporal sense of flow, but in the structural sense of space-time. Prediction exposes what is already woven into the universe, rather than creating it moment by moment. Ultimately, the ability to predict does not prove that the future must arrive. It proves only that the universe is coherent and structured. Events exist because they satisfy relationships, not because they are drawn forward by a moving present. The future is real in advance, even if it remains unknown to you. Quantum states and temporal description. Quantum mechanics evolves systems according to time-dependent equations. But these equations describe correlations between measurements. They do not require a flowing present. Interpretations differ, but the formalism remains also compatible with a static space-time containing all outcomes. The Schrödinger equation, central to quantum mechanics, governs how the wave function changes with respect to a time parameter. At first glance, this time dependence suggests motion, a progression from one state to another. But closer examination reveals that the evolution it describes is relational. It predicts correlations between potential measurements at different points along a time coordinate. The equation does not assert that anything is carried forward in a flow. It encodes patterns across a structure. Consider an electron in a superposition of energy states. The wave function describes the probabilities of detecting the electron in each state, When a measurement is performed, the outcome is revealed. The formalism allows you to calculate these outcomes based on the wave function, but it does not require the states to exist sequentially in a moving present. All the possibilities coexist mathematically. The passage of time is a label for ordering events along your world line, not a current driving the collapse or realization of a state. Even in interpretations that emphasize collapse, such as the Copenhagen interpretation, time enters only as a parameter describing when a measurement occurs. The collapse is not an event carried forward by time. It is a correlation between the system and the measurement apparatus. The outcome is constrained by the structure of the equations and the initial conditions. From a block perspective, the measurement event is already located within space-time. In many worlds interpretations, the implication is even clearer. Every possible outcome occupies a branch of the multiverse. These branches are not brought into existence sequentially by a flowing present. They exist as part of the static structure described by the wave function. Your perception of encountering one outcome rather than another reflects your path through the branching structure, not the movement of reality into the future. Decoherence further illustrates this point. When systems interact with their environments, correlations become effectively permanent. Classical reality emerges from quantum probabilities. The asymmetry you experience, one outcome observed, others inaccessible, is a result of correlations and entanglement. It is not evidence that time is advancing. It is evidence of relational structure within space-time. Quantum mechanics also emphasizes the role of information. Outcomes are constrained by prior conditions, not by a process of becoming. A measurement today is determined probabilistically by the configuration of the system and its interactions. Whether you label this before or after is a matter of coordinates. The physical laws do not insist on a universal now. This becomes especially clear in delayed choice experiments, where choices made after a particle passes a certain point affect correlations observed in the past. These results do not require retrocausation in the sense of a moving present acting backward. They reflect correlations within the static structure of space-time that is encoded by the quantum formalism. The events are located in the block. Your perception of temporal order arises from the path you occupy through it. Quantum entanglement provides a similar perspective. Two particles separated by light years exhibit correlations that are independent of the order in which measurements are performed. There is no need for a signal or a flow to enforce these relationships. The correlations exist across space-time. The wave function describes these connections without invoking passage. Even time-dependent perturbations, often used to model dynamic interactions, function in this way. The equations describe how probabilities are related across coordinates. They do not animate the system. The evolution is a map of relationships, not a process that carries events into being. Ultimately, quantum mechanics reinforces the distinction between the experience of time and the structure of time. Probabilities, measurements, and correlations are all embedded in the block of space-time. The appearance of dynamics, randomness, and change is fully compatible with a universe in which all events, past, present, and what you call future, exist. There is no flowing present. There is only the structure containing everything you will ever observe, arranged in precise, lawful patterns. The problem of the now. Despite its centrality to experience, the present moment has no clear definition in physics. Attempts to define it mathematically fail or become observer-dependent. What feels most immediate to you is absent from the most precise descriptions of reality. The concept of now seems obvious. You point to a clock or look at your surroundings and feel the present as a moving boundary. You assume that what exists is being carried forward moment by moment. Yet in both classical and modern physics, there is no universal marker of this moment. The equations describe states and relationships, not an advancing slice that carries the universe from past to future. Special relativity makes the problem immediate. Simultaneity is relative. Two observers moving differently will disagree about which events are happening at the same time. There is no single hyperplane that can be called the present for all observers. A distant supernova that seems current to you may already have occurred according to someone moving at a different velocity. The very notion of a universal now dissolves under measurement. Attempts to define now locally are also unsatisfying. You can identify the moment experienced along your own world line. This is the moment your consciousness occupies, but that is a coordinate tied to a specific trajectory. It is not a property of space-time itself. Other observers, in different positions and moving differently, occupy entirely different moments. What is present for one is neither present nor future for another. The present becomes a personal experience, not an objective feature of reality. Even in Newtonian mechanics, the present is elusive. Classical physics assumes an absolute time parameter, flowing uniformly. But absolute time is an abstraction. It does not manifest in measurements. The motion of planets, the propagation of light, and the behavior of forces do not detect the flow of time. Absolute time can be introduced to simplify calculations, but it is not required for physical predictions. The present if defined by a universal clock, is invisible. In quantum mechanics, the problem intensifies. The formalism describes correlations between events, not a moving instant. Measurements reveal outcomes that are correlated across time coordinates, but they do not identify a privileged moment in which reality is being carried forward. Delayed choice and entanglement experiments show that the order of observation does not enforce a universal now. The immediacy you feel has no counterpart in the equations. Cosmology reinforces the absence of a present. The universe's large-scale structure and the cosmic microwave background provide reference points, but they do not define a moving moment. The Big Bang is a boundary, not a tick in soar, an ongoing timeline. Expansion, structure formation, and evolution are described relationally. There is no slice of space-time that can be universally labeled as the present. This absence has profound consequences for experience. Your sense of immediacy is psychologically compelling, yet physically irrelevant. It is constructed by memory, perception, and attention. Your brain interprets sequences of events along your world line and creates the illusion of a moving now. The feeling is real, measurable in cognition and reaction, but it is an internal process imposed upon a static structure. Attempts to formalize now mathematically encounter similar obstacles. Any definition tied to simultaneity, to a particular slicing of space-time, or to local processes, is inherently observer-dependent. There is no coordinate-independent notion of a universal present. The more precisely physics describes events, the less room there is for a flowing instant. Ultimately, the present vanishes in the formal description of the universe. It is central to consciousness, immediate to perception, and unavoidable in thought. Yet it cannot be located in equations, measured by instruments, or reconciled across observers. What you feel as the moving now is absent from reality itself. The consequence is subtle but unsettling. The moment that seems most intimate, that gives you the sensation of advancing through life, is not anchored in the universe. The present is a construct, emergent from your experience, not a feature of the cosmos. What you take to be reality unfolding before you is already laid out in the structure of space-time, without need for a flowing boundary, without need for a now. Change. Without passage. Change is real. Systems differ across time. Coordinates. But change does not imply motion through time any more than variation across space implies space is moving. Difference does not require flow. Consider a tree growing in your yard. Over years, its branches extend, leaves emerge, and its bark thickens. You perceive this as the tree moving forward in time, progressing from one state to another. Yet in physics, the tree's states exist at coordinates along the time dimension. Its growth is encoded as a sequence of events in space-time. Nothing about these events requires a universal present to carry them into the next state. Each moment of the tree exists within the block. Your sense of progression reflects your perspective along the world line, not a temporal current. This principle applies across scales. A star fuses hydrogen into helium, releasing energy. Its luminosity increases and eventually declines. Measurements of stellar evolution are predictions of sequences, not indicators of passage. The star is not moving through a temporal medium. Its changes are relations among states positioned along a time coordinate. The observation of change does not imply that the universe itself is advancing. Even in particle physics, change occurs without flow. Electrons transition between energy levels. Atoms decay. Photons scatter. Each process is distinct and measurable. The probabilities of these events are governed by laws. Their differences are real, observable, and statistically predictable. Yet there is no evidence that the system is carried forward in a moving present. The events are located in space-time. They do not require temporal propulsion. Relativity reinforces this understanding. Two observers in motion, relative to each other, may disagree on the temporal interval between events. Yet both will observe consistent sequences along their respective paths. Change happens for each observer, but there is no universal clock ensuring simultaneous progression. The variation of duration between world lines illustrates that change is relational, not carried by a flowing time. Entropy further illustrates the point. Systems evolve toward higher probability configurations. Ice melts, gases diffuse, stars die. These changes create an arrow of experience. But this arrow is statistical, not causal in the sense of advancing time. The gradient of entropy is embedded in the structure of events. The sequence exists. Passage is not required for it to exist. The universe records difference without transporting states. Even consciousness is structured this way. Your thoughts, memories, and perceptions shift from one state to another. You feel this as passage, as a flow. But each mental state occupies coordinates along your world line. Neural configurations are physical events that exist independently of any universal now. The sense of moving through thought arises from correlation, not from movement through a temporal medium. Mathematics formalizes this principle. Differential equations, the backbone of physics, describe how variables relate at different coordinates. Solutions encode change. The derivative measures difference, not progression. Whether you read the derivative forward or backward, the solution exists. Change is fully captured without invoking a process that carries the system into the next value. Even in chaotic systems, small differences amplify, creating sensitivity to initial conditions. This unpredictability does not imply flow. The structure is fully specified by initial coordinates and governing laws. Complexity arises from relational patterns, not from the universe being moved forward by an invisible current. The implication is profound. Everything that appears to occur, the rise and fall of stars, the growth of trees, the flicker of neurons, the evolution of galaxies, exists as differences along a structure. Change is undeniable, measurable, and unavoidable. Passage is not. You experience change because you occupy a path through it, not because the universe is being carried forward. Recognizing this separates reality from intuition. Difference, pattern, and evolution do not require flow. The universe exhibits all these phenomena without advancing. Motion through time is a psychological inference, not a physical necessity. The world changes. That change is encoded in space-time. It does not move. Human experience as a path, not a motion. You experience a sequence because your consciousness traces a path through space-time. Each state contains records of earlier states. This creates continuity. But a path through a structure does not require the structure itself to change. Your perception of a flowing present arises from the correlations encoded along your world line. Memories, sensory inputs, and neural activity link successive states in a coherent pattern. Each state carries information about preceding states, giving the impression that experience is moving forward. Yet nothing in the physics requires that the universe itself be carried along by a current. What you call now is your position along a path through events already embedded in space-time. Consider reading a book. Each page presents information that builds upon the previous pages. You experience the story as unfolding, progressing from one chapter to the next. But the narrative exists in its entirety on the pages. The sensation of moving through the plot is internal. It arises from your position along the sequence of pages. Similarly, consciousness traces its path through the structure of space-time, interpreting correlations as movement. The movement is yours, not the universe's. Neuroscience reinforces this view. Neural states evolve in a highly ordered fashion. Action potentials propagate, synaptic connections activate, chemical gradients shift. Each of these states contains records of prior configurations, encoding continuity. Consciousness does not need the universe to advance to register these states. It only requires that the states exist and be connected in a physically consistent way. The flow you perceive is an emergent property of the path you inhabit. This perspective clarifies why you feel a directed experience of time. As you move along your world line, each state carries the imprint of the past. Memories, learned associations, and causal chains accumulate. This accumulation produces the sensation of passage, the sense that one moment leads into the next. But the passage is a feature of the path, not of the underlying structure. The universe does not advance. Your trajectory through it creates the subjective sensation of flow. Entropy and memory also reinforce the path-based view. Low entropy past states create stable records, while higher entropy states encode the results of prior interactions. This asymmetry produces psychological continuity. The direction of experience aligns with the statistical and structural properties of the universe, yet it does not imply that time itself is flowing. The structure remains static. The sensation of movement arises from the sequence of states along your path. Even decision-making can be reframed this way. You anticipate outcomes, weigh alternatives, and select actions. Each choice corresponds to a configuration of neural states. These configurations exist along your world line, embedded in space-time. The act of choosing feels dynamic, but it is an interpretation of static relations. Your consciousness moves along the path, but the path itself is already laid out. Relativity further supports this model. Each observer has a unique world line. Events that appear simultaneous to you may occur at different times along another observer's trajectory. Continuity and sequence are local experiences along specific paths, not universal features of a moving present. The structure of space-time allows each consciousness to experience continuity without requiring global flow. The block universe framework makes this explicit. Past, present, and future are all present in the structure. Your path through this block gives rise to experience. You perceive a sequence because states along your trajectory contain records of previous states. The path, not motion, explains continuity. Time does not flow. You traverse it. Ultimately, human experience is constructed from relational patterns along a path through space-time. Every sensation of succession, every impression of becoming, arises from your position relative to the structure. The universe does not advance, yet consciousness produces a compelling sense of movement. Continuity is real passage is not. You move through the universe, but the universe itself does not move. Free will in a fixed space-time. If all moments exist, choices appear predetermined. Yet physical descriptions already constrain outcomes through laws and probabilities. The tension between freedom and determinism exists regardless of whether time flows. The block does not resolve it, but it does not create it either. You experience decision-making as a process unfolding from one moment to the next. You weigh options, imagine consequences, and select an action. In ordinary perception, this implies that the future is open, that your choice brings something into existence. But in a space-time where all events are fixed coordinates, every choice you make is already embedded in the structure. Each decision exists alongside the conditions that produced it, the consequences it entails, and the observations that follow. This does not make choice meaningless. Constraints imposed by physical laws and probabilistic outcomes exist with or without a flowing present. Neurons fire, chemical gradients shift, and quantum events occur in ways that make some outcomes overwhelmingly more probable than others. The block universe merely locates these probabilities as fixed relationships along space-time coordinates. Your actions unfold according to constraints that were always present, yet you still experience deliberation and agency within those constraints. Consider a simple act, such as reaching for a cup. Muscle contractions, neural firings, and sensory feedback all interact according to physical laws. In a moving time picture, your choice brings the next configuration into being. In the block view, each configuration is already determined relative to prior conditions. The lawfully constrained path exists in its entirety. Your experience of acting remains intact, but the action is now a coordinate rather than a moment carried forward. Quantum mechanics add subtlety. Probabilistic events introduce uncertainty, but not a flowing present. Outcomes exist as correlations in the structure. Whether a particle decays, a neuron fires, or a signal is transmitted, the wave function encodes all possibilities. Your awareness follows a particular trajectory through these events, producing the experience of choosing among alternatives. From the block perspective, the probabilities are mapped out. The apparent indeterminacy is a feature of your path, not a feature of temporal flow. This preserves the phenomenology of free will without invoking a moving present. You deliberate, anticipate, and respond. Every state you occupy encodes evidence of prior states and predictions of subsequent ones. The tension between freedom and determinism is the tension between your perception of choice and the constraints of the underlying structure. The block universe makes explicit that this tension is structural, not temporal. Passage does not create the problem, nor does it dissolve it. Relativity reinforces this concept. Observers in relative motion may disagree about the ordering of distant events, but local causality is preserved. Each consciousness experiences a coherent sequence along its world line, including decisions and consequences. The structure accommodates the sense of free will along individual paths, even as all events are embedded in a fixed space-time. The implication is profound and disquieting. Your sense of agency, the conviction that you are selecting among real alternatives, is fully preserved in experience. Yet every choice is already located in the space-time block. You feel as though you are making decisions, yet the universe contains all outcomes simultaneously. The feeling of novelty, the anticipation of future action, and the reflection on past choices are internal aspects of the trajectory you trace. Even moral and psychological responsibility is consistent with this framework. You can act, learn, and be accountable because the experience of choice exists along your path. The block universe does not diminish consequences or experience. It only removes the assumption that your choices are being carried into existence by a flowing present. Ultimately, free will in a fixed space-time is a phenomenon of relational structure. The block does not force determinism any more than it nullifies agency. It situates all choices within a framework where constraints and possibilities coexist. What you perceive as freedom is the navigation of your path through this pre-existing structure. The tension between freedom and determinism is real, experienced, and measurable. Yet it does not require time to move, to exist. Choices are coordinates, deliberation is real, and you are fully inhabiting them, even as the universe itself remains unmoving. Observation does not select the present. Observing an event does not bring it into existence. It reveals information already encoded in physical states. Measurement updates knowledge, not reality. The event's location in space-time remains unchanged. Consider a star several thousand light-years away. Its light reaches you now, carrying information about its surface, composition, and motion. When you observe it through a telescope, you are not causing the star to shine or creating the photons that entered your eye. You are uncovering information that has always existed along the path between the star and your observation point. The act of observation does not select a moment to become. It only situates your awareness at a particular coordinate in space-time. This principle applies at all scales. A laboratory measurement of a decaying atom does not force the decay to occur at the instant you detect it. The decay is an event embedded in space-time. Your measurement merely correlates with it, registering an outcome that is already part of the structure. Physical laws describe the correlations between system and observer, not a temporal process that moves events from potentiality into reality. Quantum mechanics makes this distinction particularly stark. Wave functions evolve according to deterministic equations, yet the act of measurement appears to collapse possibilities into a single outcome. This collapse is often interpreted as an event becoming actual. But in interpretations compatible with the block universe, such as many worlds or decoherence frameworks, all outcomes exist. Observation does not select the present. It situates the observer along a particular path that experiences one branch. The reality of other branches is unaffected. Your awareness is updated, but space-time itself remains complete. Even in classical physics, observation does not alter the existence of events. The trajectory of a falling object, the oscillation of a pendulum, or the motion of a planet exists independently of your recording devices or attention. Instruments reveal patterns, but they do not instantiate them. The universe is not contingent on your act of observation to maintain its structure. Your knowledge is the variable. Reality is fixed. Consider an archaeological artifact. Its placement in the ground, its form, and its chemical composition existed long before anyone discovered it. Excavation and analysis provide information about the artifact, but they do not generate the object or its history. Observation registers azizo correlations within a pre-existing structure, just as measurement in physics does. The artifact is a coordinate in space-time. Uncovering it does not transport it into being. This has profound implications for your perception of immediacy. The present feels special because it is where your consciousness occupies the path through space-time. Observation reinforces the illusion of a moving now, but the universality of the present is illusory. Different observers, moving differently or positioned elsewhere, experience entirely different coordinates as now. Observation is local, personal, and path-dependent. It does not establish a global present. Entropy and memory reinforce this phenomenon. Records persist in one direction, allowing you to reconstruct the past and anticipate future events. Observation strengthens correlations and updates knowledge along your trajectory, but it does not alter the fixed sequence of events. The asymmetry of memory and thermodynamics produces the sensation of time advancing, yet the structure itself does not change. Even in complex systems, observation merely situates you within a pattern. When you measure a weather system, simulate a galaxy, or monitor neuronal activity, you access information encoded in the system's state. You do not bring any state into existence. Each outcome, each event, is already located within the block of space-time, independent of your perception. Ultimately, observation is a window, not a trigger. It updates your knowledge, aligns your experience with a particular slice of events, and enables interaction with the universe. But it does not move reality forward. What you perceive as the present is your perspective on pre-existing coordinates. The universe is complete, unmoving, and fully encoded. Measurement reveals it does not select. Awareness situates. It does not create. Observation is a doorway into the structure, not a hand that carries it along. Cosmology. Without temporal privilege. Large-scale models of the universe do not single out a present epoch. Galaxies evolve, stars form and die, but the equations describe these processes symmetrically. No moment is ontologically preferred. Cosmology relies on models built from observations of matter, radiation, and geometry, the expansion of space, the distribution of galaxies, and the cosmic microwave background all provide reference points. Yet none of these indicate a unique present. The equations of general relativity govern how space-time curves and evolves, but they do not designate one slice as the now. Every epoch is described equally, with no intrinsic distinction between past, present, or future. Consider the cosmic microwave background. It is the radiation left over from the early universe, observed today in all directions. Its uniformity and slight anisotropies give insight into conditions near the Big Bang. Yet there is nothing about these measurements that privileges today's observation. The photons reaching you now could have been measured by an observer elsewhere in space-time at a different coordinate, yielding a consistent description of the universe. Cosmological structure exists independent of when or where it is observed. Galaxies themselves illustrate this principle. Their formation, interactions, and mergers are processes embedded in the equations of cosmological evolution. The sequence of these events can be traced backward or forward, yet the formalism does not require a universal present to enforce order. A galaxy is a collection of matter at particular space-time coordinates. Its history and eventual fate are encoded in its position along the time dimension. No advancing moment is needed for its evolution. The equations simply describe the relationships between events. Even phenomena that appear dynamic on cosmological scales, such as supernovae or gamma-ray bursts, are embedded in a four-dimensional structure. Light emitted billions of years ago travels through space-time and reaches observers at specific coordinates. Observation does not bring these events into existence. The universe does not wait for them to occur. They are fixed occurrences within the overall structure. The perception of a moving present emerges because you occupy a specific world line through these events. Relativity further reinforces the absence of a privileged temporal slice. Different observers, moving relative to each other, will disagree on which cosmological events are simultaneous. What appears now to you in the Milky Way may be past or future to a distant, fast-moving observer in another galaxy. There is no universal present that the universe recognizes. Each observer's path through space-time provides a local experience of sequence, but the underlying structure is complete and static. Even the concept of cosmic time is a coordinate convenience. Cosmologists often describe epochs according to the age of the universe since the Big Bang. This provides a framework for modeling evolution, but it does not imply that the present epoch is ontologically special. The early universe, the formation of stars, and the far future all exist equally within the structure. The equations themselves are time-symmetric in many respects. They do not assign priority to any particular instant. Thermodynamics and entropy do not alter this picture. The growth of disorder provides a direction for experience, but it does not select a privileged moment in cosmology. The increasing entropy in stars, interstellar gas, and black holes produces asymmetry along world lines. But the universe's structure as a whole remains complete. The arrow of time is experienced, not enforced by a moving present. Even theoretical constructs, such as inflation or dark energy, are described through equations that apply across all coordinates. The expansion of space, the acceleration of galaxies, and the evolution of density fluctuations are constrained by laws and initial conditions. No step requires that one moment be more real than another. What is observed at one epoch is a coordinate within a fully specified space-time manifold. Ultimately, cosmology demonstrates that the universe does not privilege now. Large-scale processes, the evolution of galaxies, and the distribution of matter occur within a structure that is complete, symmetric, and observer-independent. The sense of being at the center of time is entirely local and contingent upon the path you trace through space-time. No equation, no measurement, and no observation singles out the present. The cosmos, in its vast totality, contains all events equally, without requiring passage, flow, or a moment to be special. The language trap. Words like before and after imply motion. They shape intuition. But the underlying descriptions rely on relations not transitions. Language suggests becoming where physics finds structure. From early childhood, you are taught to organize experience temporally. Events are sequenced with terms such as earlier, later, previous, and next. This linguistic framework embeds the notion of a flowing present into thought itself. It encourages the perception that reality is continually being carried from one moment into another. Yet in the formalism of physics, these terms are conveniences, not necessities. Equations describe correlations, constraints, and relationships among events. There is no requirement that anything moves to occupy a next moment. Consider a train timetable. It lists departures and arrivals. The terms avant, before, and after help navigate the schedule, yet the trains themselves exist in positions along tracks at particular times. The timetable describes relationships between locations and times. The words imply movement, but the physics of the trains, their coordinates in space and time, do not require a moving present. Similarly, language for events often imposes an intuition of temporal flow that is not present in the underlying reality. In physics, events are labeled along coordinates. A particle collides at a point. A star explodes at a coordinate, and a photon scatters at a specific place and time. These events are fixed in space-time. When you describe one as occurring before another, you are mapping human intuition onto relational structure. The formalism itself relies on intervals, ordering, and causality, not on motion from a prior moment to a subsequent one. Even the phrase flow of time is misleading. Time is treated mathematically as a dimension akin to space. Motion through space is measurable because displacement produces observable effects. Motion through time, by contrast, has no measurable counterpart. The intuition of flow is linguistic, not physical. Words carry with them the weight of everyday experience, but they obscure the distinction between sequence and passage. Relativity complicates the matter further. What is before or after depends on the observer's frame of reference. Two observers, moving relative to each other, may disagree about the order of distant events. Language fails to capture this nuance. It embeds an assumption of universal simultaneity that does not exist. The formalism replaces intuition with precise relations, coordinates, intervals, and light cones define causality without invoking a moving present. Quantum mechanics provides another example. When describing measurement sequences, we speak of prior and later outcomes. Yet the wave function encodes correlations among all events. There is no ontological flow connecting potential outcomes. The relations exist statically within space-time. The terminology suggests becoming, while the mathematics describes structure. Observation and calculation update knowledge along a path, not reality itself. Even memory and anticipation are shaped by language. You narrate experience in terms of what came before and what will come after. Each memory or forecast feels like evidence of passage. But in the block universe, memories are coordinates, and forecasts are correlations among events. The linguistic framing encourages an illusion of motion that is not present in the underlying structure. The brain interprets sequential differences as passage, and language reinforces this interpretation. Thermodynamic and statistical asymmetries are also described linguistically in ways that suggest flow. Entropy increases, systems evolve, processes progress. Yet the physical interpretation remains relational. Each state exists relative to others. Ordering does not imply movement. The sensation of progression is emergent, dependent on your path through a structure that is already complete. Ultimately, the trap of language is pervasive. Words like before, after, progress, and flow shape intuition to expect motion where there is none. Physics describes structure and relationships, not a universe being carried forward. The distinction between language and formalism is subtle but decisive. Reality is static in its structure, and the sense of becoming arises from perspective, path, and interpretation, not from the movement implied by the words we use. Why the future feels open. Uncertainty about future measurements gives the impression that the future is unreal. But uncertainty reflects limited information, not non-existence. Ignorance does not define ontology. When you predict tomorrow's weather, you recognize that the exact pattern of temperature, pressure, and precipitation is unknown. You interpret this uncertainty as evidence that the future is open, that it has not yet been determined. Yet the underlying physical system evolves according to well-defined laws. The atmosphere occupies a configuration along the time coordinate, whether or not you know its state. The unpredictability resides in your knowledge, not in the existence of the events themselves. Consider a coin toss. Before observation, you may not know the outcome, so it seems as if both possibilities are equally real, and the final result is undetermined. But the toss follows physical laws governing motion, gravity, and air resistance. In principle, if every variable were measured precisely, the outcome could be computed. The event itself exists as a coordinate in space-time, fully determined by conditions, independent of your ability to predict it. The sense of openness is a reflection of epistemic limitation, not temporal incompleteness. Quantum mechanics complicates intuition, yet it does not contradict this principle. Probabilistic outcomes give rise to apparent indeterminacy. A measurement of a quantum system may yield one result out of many possibilities. From your perspective, the outcome is unknown, and the future feels open. Yet the wave function encodes all possible correlations in space-time. Every outcome is part of the formal structure. Observation reveals which branch your path experiences, but it does not create or delay the existence of events. Ignorance remains local and personal. The events themselves are fixed. Even on cosmic scales, uncertainty does not negate reality. Galaxies interact gravitationally over billions of years. Observers cannot precisely predict every interaction. The future appears indeterminate, yet the universe contains these interactions as coordinates along space-time. Predictive limitations are epistemological, not ontological. The laws of physics and the initial conditions of the cosmos already define the sequence of events. The seeming openness of the future is a feature of perception, not of structure. Memory reinforces this illusion. You remember the past because physical records exist in one direction of the entropy gradient. This asymmetry gives you a sense of sequence. You anticipate the future because you lack these records. The contrast between known past and unknown future produces the compelling impression that the future is not yet real. Yet the asymmetry does not require that events are being carried forward. Your experience of anticipation occurs along a path through pre-existing states. The uncertainty you feel is tied to perspective, not to the universe's structure. Decision-making also contributes to the sensation of an open future. We deliberate, weigh options, and act in ways that seem to create outcomes. But in a block universe, each decision and its consequences occupy fixed coordinates. The experience of choice, including the uncertainty and suspense that accompanies it, is a consequence of the structure of your path. You perceive options and potential outcomes, yet all are already embedded in space-time. The openness is felt, not instantiated. Even statistical modeling illustrates this principle. Probabilities quantify expectation, not creation. A model predicts the likelihood of an outcome, but the events themselves are already determined within the coordinate framework. Probability is a tool for managing ignorance, not evidence that events are unreal. Your uncertainty does not alter the location or reality of the outcome. Ultimately, the future feels open because your knowledge is incomplete, your path is limited, and correlations are experienced sequentially. The sensation of becoming, of potentiality, is an analiza, emergent feature of perception and cognition. Reality, however, is encoded in a four-dimensional structure where all events exist. Uncertainty is a mirror of limitation, not a gap in existence. The future is already real, even if it is unknown to you. The cost of accepting the block. Accepting that all moments exist removes the comfort of a moving present. It challenges responsibility, meaning, and anticipation. These costs are psychological, not empirical. The measurements remain unchanged. From the perspective of lived experience, a flowing present provides reassurance. You navigate life assuming that the future is open, that your actions have causal power to shape what comes next. You anticipate outcomes, plan, and evaluate consequences. Accepting the block universe disrupts this intuitive framework. All moments, the past you recall, the present you inhabit, and the future you imagine, exist as coordinates within a four-dimensional structure. The psychological sense of novelty, suspense, and becoming is reframed as an emergent property of your path, not evidence of temporal flow. Responsibility feels different under this view. You hold yourself accountable because choices appear to bring the future into being. In a block universe, choices are embedded in space-time along with consequences. Yet the experience of deliberation and moral evaluation remains intact. You perceive responsibility because your path through the structure carries records of past decisions and constraints on future outcomes. The structural embedding of events does not eliminate agency, but it dissolves the notion that you are dynamically producing moments as you move through time. Responsibility is encoded along your trajectory, inseparable from the sequence you experience. Meaning, too, is affected. Narratives of growth, progress, and transformation are built on the assumption that time flows. Achievements are seen as stepping stones, and failures as temporary obstacles. If all events already exist, this narrative becomes a static structure rather than a dynamic story. Yet the phenomenology of meaning does not vanish. Your perception of continuity, of causally linked experiences, remains. Meaning is relational. It arises from patterns of experience along your path, even if the universe itself does not advance. The absence of flow does not remove significance. It relocates it from objective passage to subjective trajectory. Anticipation is equally challenged. Planning and expectation assume that future states are not yet fixed. In the block universe, every anticipated moment is already encoded. You do not bring the future into being. Your consciousness traces the path through the pre-existing structure. The sensation of suspense, curiosity, and surprise is a product of your local perspective. Each future event is predetermined along your world line, but your awareness encounters it sequentially. The emotional experience of waiting, hoping, or fearing is real, yet it is decoupled from the universe producing a flow. Psychologically, these revelations can feel destabilizing. The illusion of time passing is deeply ingrained. Language, memory, and culture reinforce it. Accepting the block requires adjusting intuition to match observation. The passage you feel is a property of your path, not of reality itself. There is no empirical contradiction here. All measurements, whether of clocks, stars, or quantum events, remain consistent. The universe behaves precisely as physics predicts. Only the interpretation of experience is altered. Even uncertainty and probability must be reframed. The future seems open because you lack information, not because it does not exist. Your predictions are tools for navigating ignorance along your path, not instruments that shape what comes next. Anticipation, planning, and imagination remain functional and psychologically meaningful, even though the events themselves are fixed coordinates in space-time. Ultimately, the cost of accepting the block is cognitive and emotional. It shifts the locus of experience from a moving present to a path through a static structure. Responsibility, meaning, and anticipation are preserved phenomenologically, but the comfort of believing that you are dynamically shaping reality is lost. The universe is complete, unmoving, and fully encoded. The measurements, correlations, and laws that govern events are unchanged. What changes is the lens through which you interpret experience. Passage is a feeling. Reality is structure. The psychological cost lies in reconciling these two. What would flow require? For time to flow, there would need to be a second time parameter relative to which it moves. No such parameter appears in any tested theory. Introducing one creates more problems than it solves. If the present were genuinely advancing, you would expect a mechanism to carry moments from potentiality into actuality. Motion requires a frame of reference, a dimension along which displacement occurs. In space, this is evident. Distances are measured relative to coordinates. Velocities produce measurable effects, and motion can be quantified. If time itself flows, there must be a similar reference along which temporal displacement occurs, a meta-time or second temporal dimension. Yet no physical law, measurement, or observation provides evidence for such a structure. Introducing a second time parameter raises immediate contradictions. For motion to be meaningful in this new dimension, it would require yet another time to define its progression. This leads to an infinite regress. a sequence of times measuring the flow of the previous time, with no end point. Each level would demand its own laws, clocks, and interactions. The universe we observe does not display any evidence of these layers. There is no second time hidden within measurements, no experimental signature, no deviation from predictions that would necessitate an advancing temporal substrate. The idea of flow also conflicts with relativity. In Einstein's framework, the temporal coordinate is intertwined with space into a four-dimensional manifold. All events are located within this structure. There is no external reference to define a universal rate of passage. Different observers, moving relative to one another, measure intervals differently. If time were flowing relative to a second temporal dimension, there would need to be an invariant speed of passage across observers. Experiments consistently contradict this possibility. Observed durations vary with motion and gravity, demonstrating that flow is not a universal property. Clocks themselves provide no evidence for temporal flow. They measure intervals, not progression. A ticking second does not advance the universe. It counts repeated processes. Oscillations, rotations, vibrations, all measure change relative to themselves, not movement along a meta-time. The completeness of physical laws does not require that events be carried forward. The sensation that time passes is an emergent feature of consciousness moving along a path in space-time, not a physical effect of flow. Even at the quantum scale, the introduction of a secondary temporal dimension produces paradoxes. Schrödinger's equation evolves systems relative to a single time parameter. Probabilistic outcomes are encoded in correlations, not in a temporal medium that moves. Introducing a second time would require redefining causality, measurement, and entanglement. The neat symmetry of the formalism would collapse. No additional dimension is needed to account for the results we observe. All outcomes are fully represented along the original temporal coordinate. Thermodynamics and entropy further illustrate the point. The arrow of time is often associated with increasing disorder, but this gradient does not imply a moving present. The statistical tendency toward higher entropy exists as a pattern across coordinates. There is no need for an advancing moment to enforce it. Introducing flow would demand a new mechanism to propagate low entropy states forward, yet no such mechanism appears in either observation or theory. The laws are complete as they are. Accepting the block universe removes the necessity of flow and avoids infinite regress. Past, present, and future are embedded in a single structure. Events exist as coordinates, causally related and constrained by physical laws, without requiring motion through an additional temporal dimension. Consciousness traces a path along these coordinates, creating the impression of passage. The universe is fully determined, yet your experience of continuity, change, and succession remains real. Ultimately, for time to flow, a second time would have to exist, a meta-parameter to measure movement along the first. No empirical evidence supports this. Every attempt to introduce it generates unresolved contradictions of the structure of physics, functions without it. Flow, when examined rigorously, requires more than is observed and is therefore unnecessary. Passage is a perception. Reality is a structure. Time does not move. A universe that does not wait. The equations describing reality do not pause for you to arrive at the next moment. They already include it. If time does not pass, then existence is not unfolding. It is already laid out, indifferent to how it is experienced. When you look at the night sky, you perceive stars twinkling, planets rotating, and galaxies drifting across vast distances. Intuition suggests that these events are happening now, in a sequence that advances before your eyes. Yet the formalism of physics does not rely on your observation. The positions, velocities, and interactions of these celestial bodies are fully described by coordinates in space-time. The universe does not wait for your awareness to reach the next instant. Each event exists as a location in a four-dimensional structure. Consider the orbit of Earth around the Sun. You see days pass and seasons change, giving the impression of continuous progression. Physics, however, encodes every point along Earth's orbit. Its trajectory is fully specified by initial conditions and the laws of motion. There is no moment in transit for the planet to occupy. Your perception of the sun rising and setting is tied to your local path along space-time, not to a cosmic flow pushing the universe forward. This principle applies equally at microscopic scales. Electrons transition between energy levels, photons scatter through matter, and atoms undergo decay. Each of these events is already a coordinate in space-time. Measurement does not summon the event into existence. It merely correlates your awareness with the pre-existing structure. The universe's completeness is indifferent to observation. The block contains all possibilities realized, whether or not a conscious agent is present to register them. Even complex systems, like weather patterns or ecological networks, follow the same principle. Storms form, rivers swell, forests grow, and die. These sequences of events are embedded in the structure of space-time. No event waits for an observer or for a next moment to arrive. Predictive models map correlations and sequences, but they do not cause anything to occur. The universe is not unfolding before your eyes. It already exists in its entirety. Relativity reinforces the indifference of the universe. Different observers in motion, relative to each other, disagree on simultaneity and intervals. Yet each measures consistent outcomes along their world line. The universe contains all events across all perspectives. It does not pause or advance. It simply encodes relationships. Your experience of flow is local and path-dependent, not universal. Quantum mechanics adds a layer of subtlety, but not contradiction. Wave functions evolve deterministically according to time-dependent equations, yet the potential outcomes are already represented in the formalism. Measurement does not summon one possibility into existence. It aligns your consciousness with a particular coordinate. The universe does not wait. Probabilities are tools for managing limited information, not evidence of unfolding reality. Memory and anticipation are equally path-dependent. You remember the past because states along your world line contain records of prior events. You anticipate the future because those coordinates are yet to be encountered along your path. But the universe does not carry states forward to meet you. All events, past, present, and future, exist as coordinates. The sensation of continuity arises because your consciousness traces this trajectory. Even on the largest scales, cosmology exhibits indifference. The expansion of space, the evolution of galaxies, and the formation of cosmic structures occur across coordinates that are fully specified by initial conditions and physical laws. No epoch waits for your attention. The universe's structure is complete. Your awareness merely moves through it. Ultimately, the universe does not wait. It is fully encoded, indifferent, and complete. The sensation of becoming, of witnessing events unfold, is generated along your path. Existence is not emerging. It is. Time does not carry reality forward. Your perception of motion, change, and succession is real. But it traces a structure that was never in motion. The cosmos is laid out in its entirety, and it does so without pause, without anticipation, and without concern for you.